Hello everyone, welcome to my channel. Keep exploring. In today's video, we are going to discuss exercise 2.2 of the chapter Polynomials class 9. Before we start the exercise, let's go through few basics. To start with, how to find the value of a polynomial. Let us consider a polynomial p of x that is equals to 5x squared minus 3x plus 7. So in this, the value of the polynomial p of x at x equals to 1 is given by p of 1. That is, in place of x, just you have to put 1. As it has been given, find the value of p of x at x equals to 1. So wherever we have x, we have used 1. So we get 5 into 1 squared minus 3 into 1 plus 7. And 5 into 1 squared is 1, so 5 ones are 5, 3 ones are 3 plus 7, 5 minus 3 is 2, 2 plus 7 is 9. So here p of 1 is equals to 9. So 9 is the value of the polynomial at x equals to 1. Similarly, we can find p of 2 or p of 3 or even p of minus 1, p of minus 2 and so on. Next, verifying the zero of a polynomial. So let's see what is the zero. Consider the polynomial p of x is x minus 1. So what is p of 1 here? That means in place of x, let's put 1. So here we see that p of 1 is nothing but 1 minus 1, that we get 0. So here 1 will be called as the 0 of the polynomial p of x because we got p of 1 as 0. So 1 is the 0 of the polynomial p of x because on replacing x in place of x, when we put 1, we get 1 minus 1, that is 0. So here 1 is the 0 of the polynomial p of x. Similarly, we can check that 2 is the 0 of qx where q of x is x minus 2. That means in place of x, if we put 2, the whole polynomial becomes 0. So in general, we can say that 0 of a polynomial p of x, 0 of a polynomial p of x is a number c such that p of c is 0. Next, finding the 0 of a polynomial. In this case, we must have observed that 0 of the polynomial x minus 1 is obtained by equating it to 0. That is, if we put x minus 1 as 0, we get x equals to 1. And we know that 1 is the 0 of the polynomial. So here we say that p of x is equals to 0 is a polynomial equation and 1 is the root of the polynomial equation p of x is 0. So we say 1 is the 0 of the polynomial x minus 1 or a root of the polynomial equation x minus 1 equals to 0. So here for this polynomial x minus 1, 1 will be called as the 0, or for the polynomial equation x minus 1 equals to 0, 1 will be the root of the polynomial equation, or sometimes we call it as the solution of the equation. So let's start now the exercise 2.2. The first question says, find the value of the polynomial 5x minus 4x squared plus 3 at x equals to 0, x equals to minus 1 and x equals to 2. So let's start. So when x equals to 0, what will be the value of 5x minus 4x squared plus 3? So here in place of x, just you have to use 0. So we'll put 0 in place of x. So 5x is nothing but 5 into 0 minus 4 into 0 squared plus 3. So 5 zeros are 0 minus 0 square is 0. So 4 zeros are 0 plus 3. We get finally 3. So this is the value of the polynomial at x equals to 0. Moving on with the next one. For the same polynomial, 5x minus 4x squared plus 3. So here we have the negative value. So x is minus 1. So better to keep it inside brackets. Minus 1 whole squared plus 3. So first we'll solve the powers, then we'll go for the multiplication. So 5 times minus 1 minus 4 times minus 1 whole squared. So minus 1 whole squared is only 1. So that is minus 1 into minus 1 plus 3. Now let's solve the brackets. 5 times minus 1 is minus 5 and 4 times 1 is 4 plus 3. So minus 5 minus 4, that is minus 9. Minus 9 plus 3, we get minus 6. The last one, 5x minus 4x squared plus 3. So 5 times x, that is 5 times 2, minus 4 times x squared. So 2 squared plus 3. So let's solve the powers. 4 multiplied by 2 squared is 4 again plus 3. So 5 times 2 is 10, 4 times 4 is 16 plus 3. 10 minus 16, we get minus 6, and minus 6 plus 3, we get again minus 3. Next, find p of 0, p of 1 and p of 2 for each of the following polynomials. Here, let's start with the first one. P of y is given as y squared minus y plus 1. So first, let us find p of 0. So p of 0 is 0 square minus 0 plus 1. That is 0 squared is 0. 0 minus 0 plus 1. We get only 1. Then p of 1, we get 1 squared minus 1 plus 1. 1 squared is 1 minus 1 plus 1. We get 1 minus 1 is 0. 0 plus 1 is 1. Next, p of 2. So in p of 2, same thing. 2 squared minus 2 plus 1. So 2 squared is 4. 4 minus 2 plus 1. 4 minus 2 is 2. 2 plus 1 is 3. Similarly, we can find the values for the next polynomial, that is p of t is equals to given 2 plus t plus 2t squared minus t cubed. So let's find p of 0. So wherever t is there, we'll replace it with 0 minus 0 cubed. So 2 plus 0 plus 2 into 0 square. 0 square is 0, 2 zeros are 0, minus 0 cube is 0. Finally, the answer is 2. Next, p of 1, that is 2 plus 1 plus 2 times 1 squared minus 1 cubed. So we get 2 plus 1 plus 2 ones are 2 minus 1. So finally we get 2 plus 1 is 3, 3 plus 2 is 5 and 5 minus 1 is 4. In the same way we can find for p of 2. So let's see this. P of 2. So we get 2 plus 2 plus 2 times 2 squared minus 2 cubed. So we get 2 plus 2 plus 2 squared is 4. So 4 twos are 8. Minus 2 cube is also 8. So plus 8 and minus 8 cancels each other. 2 plus 2 becomes 4. The third bit, p of x is x cubed. So p of 0 will be 0 cubed, that is 0. P of 1 will be 1 cubed, that is 1. And p of 2 will be 2 cubed, that is 8. The last set of question, p of x is x minus 1 and x plus 1. So p of 0 is 0 minus 1 multiplied by 0 plus 1. So 0 minus 1 we get minus 1, 0 plus 1 we get 1. So minus 1 into 1 we get minus 1. Next, p of 1. So we can write like 1 minus 1 multiplied by 1 plus 1. 1 minus 1 gets us 0, 1 plus 1 becomes 2, and 0 2s are 0. The last value, p of 2. So x minus 1 into x plus 1 can be written as now 2 minus 1 into 2 plus 1. So 2 minus 1 is 1 and 2 plus 1 is 3. So we get 1 times 3, that is 3. Moving on with the next question. Verify whether the following are the zeros of the polynomial indicated against them. See the first bit, it's given p of x is equals to 3x plus 1, where x equals to minus 1 by 3. So let us find out p of minus 1 by 3. So we get, in place of x we'll put minus 1 by 3 plus 1. So 3 and 3 gets cancelled. We are left out with a minus 1 plus 1, that is 0. And we have learnt earlier, if p of minus 1 by 3 is 0, then x equals to minus 1 by 3 will be the 0 of the polynomial p of x. So here, yes, minus 1 by 3 is the 0 of the polynomial. Second bit, p of x is given as 5x minus pi, where x equals to 4 by 5. So we will find out p of 4 by 5. So that is 5 times 4 by 5 minus pi. So we cancel 5 and 5. We are left out with 4 minus 5, and it is clearly not equals to 0. Since it is not equals to 0, 4 by 5 is not a 0. Next, the third bit says that p of x is x squared minus 1, and it has two values, 1 and minus 1. So let us check. First we'll check for 1. So p of 1 is 1 squared minus 1. So 1 squared is 1, minus 1 we get 0. Since we get 0, 1 is the 0 of the polynomial p of x. Now let's check for p of minus 1. So minus 1 whole squared minus 1. So wherever x is there, we have replaced it by 1 and minus 1. That's it. So minus 1 whole square is 1. 1 minus 1 is 0. So here it is also the, so 0 is also the 0 of the polynomial. Last bit, p of x is x plus 1 into x minus 2, where x is equals to minus 1 and 2. So let's see p of minus 1. So wherever x is there, we'll just replace it by minus 1. So minus 1 plus 1, again minus 1, minus 2. So let's see, minus 1 plus 1, we get it as 0. So 0 into minus 3, that is also 0. So p of minus 1 becomes 0 at x equals to minus 1. So here minus 1 is the 0. Now we'll check for p of 2. So here we write minus 2 plus 1 and minus 2 minus 2. So minus 2 plus 1 is minus 1, and minus 2 and minus 2 we get minus 4. So minus 1 and minus 4, when we multiply we get 4, and it is not equals to 0. So 2 is not a 0. So x equals to 2, the value 2 is not a 0. Next, p of x is given as x squared. P of x is x squared, where x equals to 0. So if p of x is x squared, then p of 0 will be 0 squared, that is 0. Since the p of 0 is 0, here 0 is the 0 of the polynomial. Sixth bit, p of x is given as Lx plus m, where x equals to minus m by L. So we'll find out p of minus m by L. So that becomes minus m by L plus m. Now L and L gets cancelled. we are left out with minus m plus m, it becomes 0. So here minus m by L is a 0. The next bit says P of x is 3x square minus 1, and we have to check it for minus 1 by root 3 and 2 by root 3. So let's see P of minus 1 by root 3. So in place of x, we'll just use minus 1 by root 3. So 3x squared. So x squared, so minus 1 by root 3 whole squared minus 1. So when we solve the powers, minus 1 by root 3 whole square. So minus 1 square is 1 and root 3 square is 3 minus 1. So we get 3 and 3 gets cancelled. We are left out with 1 minus 1, that becomes 0. So here, yes, minus 1 by root 3 is a 0 of the polynomial p of x. For the second bit, so p of 2 by root 3 we must find. So p of 2 by root 3, let's see. So 3 times 2 by root 3 whole squared minus 1. So we get 3 times 2 squared is 4 and root 3 squared is 3 minus 1. 3 and 3 gets cancelled. We are left out with 4 minus 1, that is 3, and clearly 3 is not equals to 0. So 2 by root 3 is not a 0 of the polynomial p of x. The last one here, it says that p of x is 2x plus 1 and x equals to 1 by 2. So p of 1 by 2, let's find out. So 2 times x, that is 2 times 1 by 2 plus 1. 2 and 2 gets cancelled. We are left out with 1 and 1, that is 2. And it is obviously not equals to 0. So 1 by 2 is not a 0 of the polynomial p of x. The fourth question says, find the 0 of the polynomial in each of the following cases. As we have seen how to find the 0, just we'll form a polynomial equation. Here we'll first write p of x as 0. So that means x plus 5 is equals to 0 is the polynomial equation. Here x equals to 5 is added on the left, it will be subtracted on the right. So we get x equals to minus 5. So here x equals to minus 5, this minus 5 is the 0 of the polynomial p of x. Next, again, we will form the polynomial equation. P of x is x minus 5, that is 0, and we get x equals to 5. So 5 is the 0 of the polynomial p of x. Next, p of x as 0, so 2x plus 5 is 0. So 2x for 5 becomes minus 5 onto the right. Then 2 is multiplied on the left, so it will be divided on the right. So x equals to minus 5 by 2. This minus 5 by 2 is the 0 of the polynomial. Next, p of x is given 3x minus 2. So we can write p of x as 0 implies 3x minus 2 is 0. Just solve the equation. 3x becomes minus 2 becomes 2 and 3 is multiplied on the left. So it will be divided on the right. So 2 by 3 is the 0 of the polynomial p of x is equal to 3x minus 2. Next, again, fifth bit, p of x is 0. So 3x will be 0 and here x we get as 0 by 3, that is 0. So here we say that x equals to 0. So here 0 is the 0 of the polynomial. So when I say 0 is the 0 of the polynomial, the first one 0 is the numerical one and it is the 0 of the polynomial, that is the root of the polynomial. Next, p of x is ax, so p of x will be 0. Now, ax is equals to 0, x equals to 0 by a, and we know that 0 by a will be 0. So here also, this 0, numerical 0, is the 0 of the polynomial p of x is equals to ax. Here it has been mentioned that a is not equals to 0, as we know that no number can be divided by 0. It doesn't exist. It's not defined. So the last bit, p of x is equals to cx plus d. So we can write Cx plus d is equals to 0. So Cx becomes minus d and x becomes minus d by c. So this will be the 0 of the polynomial p of x is equals to Cx plus d. Thank you for watching.